Hey, hello, and welcome to JP's Product Pick of the Week. It is me, JP, and I am here yet again with a very cool Stemma QT sensor. I don't know if you've noticed a theme here, but this is something that we like a lot. And so I've been picking a bunch of these great Stemma QT sensors. Before I reveal what it is, I will semi-reveal what it is by telling you, you probably want to head over to this very page right here. I've pointed the wrong way again. No, I haven't. That QR code is going to get you over to this URL, which is adafruit.com/product/4698. And we have a tremendous 50% off discount today on the product. If you head over there, you can get in on that action. And that is only going to be good during the live broadcast, and then a few minutes afterwards is a grace period. So if you're seeing a recap of this later, we're sorry, it was only live while the show was live, but head there now. In fact, I'm going to head over there. You'll get a little sneak peek of what it is, where we're going to be checking this out. So head on over to this product page. It's product 4698 is the product ID. I'll reload my page right now. And I should see that, wow, this thing is down to $7.98 instead of $15.95. But before I even talk about what it is, even though I've given it all away, let's have Lady Ada tell us all about it. Take it away, Lady Ada.
Ooh, this is a cool sensor. So this is a new sensor that Brian Sedacious put together, and it took a couple weeks, but it was worth it. So this sensor is a multi-spectral sensor. It has 10 color sensors inside of it, like different wavelengths. You can see the wavelengths in the back: 415, 445, 480, 515, 555, 590, 630, 680, clear and near IR. So, you know, you've got 8 visible colors, 1 clear, which is kind of like, you know, general white, overall lux, and then near IR. And it can measure these separately as individual bins, and that's kind of neat because you can do, it's a very small, very basic spectrometer that works over I²C. It's very inexpensive considering what you're getting with it, and I think it can be really useful for science projects, or it's used for you know, detecting the true color of lights or monitors to calibrate. I think it can be really cool for like some science or sensor projects. It's a very interesting new sensor.
All right, I'm going to do a kick on the server to see if we can get all. All right, I think we should be back in action, and hopefully we've got good audio sync. So that is right. That is our product pick of the week. So my product pick of the week this week is the AS7341. There it is right there. In fact, I'm going to jump back in time again and go get it, because I don't have it right now. What are we talking about? Hold on. Yes, that's right. That is my product pick of the week. It's the AS7341. It is a multi-spectral light and color sensor. It has 10 different channels of light sensing, and I believe those are 16-bit each. So we can get a whole bunch of different visible wavelength sensors. In fact, 8 of those little sensors inside of there are for visible wavelength, and then we have one for what's sometimes called clear, but is actually overall brightness or lux, and there's a near infrared one. So this sensor, I wanted to show you a couple of pretty cool demos with it. So first of all, let me show you how I've got it hooked up here. So this is my sensor. That's the AS7341, and I have it plugged into an itsy bitsy little Stemma QT connector on there. You can see also I got some poster putty. This was before we started selling boards that had those built on, so I like using this one. On this one, I'm running an Arduino sketch, and if I open up the Let me bring this up here. I'm going to open up a Arduino session. What you're going to see here is that I have the plotter inside of Arduino, which is plotting a few of those channels. What do we have? 5 channels of color. And this was mostly done to match the available graph colors that are inside the Arduino plotter. We actually have more of them we can plot, and I'll show those in a second. And what I'll do is, I'll show one use of it. I'm going to take a little necklace. This is a little Christmas lights necklace, and I'm going to cycle through its modes there until it's steady colors. And what you'll see here is, if you watch my graph, if I take one of these bulbs and hold it over, you can see there the values that it's getting in the red, I think that, what is that, the 680 nanometer range? I forget now, I might have those totally wrong. And now if I take a yellow and drop that on, you'll see this is going to be mostly made of the orange component, that wavelength section. Here we can pop a green one on there, and again you'll see the graph change. And lastly, I have on here a blue one, and I think this one shows up quite a bit in the indigo and blue. I think there's blue, indigo, and cyan to put names to some wavelengths. And so if we pop out of here, let me pop back out of here for a second, and I will go over to the product page for this. So here you're going to see, first of all, there's the product. We have it for this 50% discount during the show. If we scroll down here, you can go to the Learn Guide for it, just by clicking on this here. And here's our Learn Guide. So on here, it talks about the different color bands that we can read. I wanted to show this because if you see this little sensor package, that's the actual sensor. So it's a tiny little blob right in the middle of this STEMMA QT board that we have here. So a lot of this is just to make it all work easily and break things out. But that's that little package there. And you can even see in there are the little 10 sort of grid of sensors. They're actually tiny fiber optics, I believe, that run pointing out and then to the chip itself. And this talks a little bit about how the sensing works. One thing you'll also notice on it, so this chip, the chip we're using on here actually has some GPIO on it. One of the GPIO pins we're using is for that little white LED that you see on the top there. You can also see it on my overhead. So the reason I bring this up is that you may ask, well, what sorts of things is this good for? It's actually good for both emissive light, so trying to figure out the color of a light source, a bulb of some kind, a monitor. It's also useful for reflective light off of, particularly useful off of diffuse surfaces. So if you want to take a paint sample and find out its color versus some other paint sample, in those cases you're going to need a light source, and you're going to need that light source to be consistent. So we actually have this little white LED built onto here that you can turn on in your code and calibrate to that so that you have consistency. Clearly you'll need to block ambient light, outside light from bleeding in and changing your results. So you typically with something like this you'll build a little sort of tube that will go onto your object so that just your light that you're reflecting and your sensor are the only things involved bouncing off that surface. And one of the questions is, well, what are these used for? If you click on the downloads page and head over to the data sheet, you'll see here they mention applications, high precision, reflective color, point and spectral measurements, fluid color, turbidity, or reagent-based constituent analysis. So this is useful in laboratory settings. Spectral power distribution and passive ambient CCT measurement for home and building automation. And these are actually used in, it also says high-end display color management. So there are a lot of color calibration devices used in things like publishing and film that you use to get consistent color between monitors and final output. So this can be used in that. One thing that if you go to the website for AM, I think AM2, is that the company who makes this? No, AMS, sorry. If you go to AMS's site and look at this product, they talk a lot about it being used in smartphone cameras. So one thing you'll find is when you take pictures with any modern camera or phone camera particularly, there's an automatic white balance that is keeping your outdoor photos from looking blue tinted and your indoor photos under incandescent lights from looking orange tinted. And a lot of that is the job of a sensor like this to say, well, what color am I collecting in here that's sort of tinting things? Now we're going to undo that. So computationally fixing your white balance for you so that your photos do the same thing human eyes do, which is compensate for the overall ambient lighting conditions. So you'll find these are used a lot in cameras and phone cameras because it's so tiny and it's able to get very, very high quality results on a bunch of these different wavelengths so that we can get nice photography that isn't color cast one way or another. I mentioned that if we look at the guide for this, it talks about uses, also talks about how you can set it up both inside of Arduino, and so there's a page here on using an Arduino, and that's this example I have here. I also have another example where I have this happens to be a Metro M4 airlift that I'm running a CircuitPython sketch on. So I'm going to go ahead and plug in my board over the Stemma QT, which makes it really straightforward to plug and play. So my board is plugged in. I'm going to actually switch out and grab that power cable here. We won't be using that serial output in this demo. I'll put some power to this board, and let me put this in the overhead for you. So let me move this out of the way. And what I've got with this demo, let's reuse some of this poster putty, is let's hit reset on there. I have a very hastily put together sketch which will attempt sort of to match the color that it sees. So I'm going to again turn on my little Christmas lights here until they're steady. And you'll see now if I take a bulb and hold it over my color sensor, let's see, this might not be rebooted. Let's try. We should get it attempting to match. It might not be working now. Live demo. Did I unplug something? Let's just double check. Oh, looks like it's all working. All right, I think I've broken it, but I had this working where this set of neopixels here, this little neopixel ring, was. I'll try one more time to power cycle it actually. Taking a color reading using our AS7341 and then attempting to match the closest possible color. But yeah, I've pulled something apart and it's not going to work for us. But that's one potential use. And an interesting thing here is we have a lot more color depth. I mentioned that if we look at some code here, in fact, I'll show the code that should have worked there and decided not to. Let me pop open my Atom. Is this it? Yeah, okay. So if you look here, this is in CircuitPython. It's not too different in Arduino. This is pretty simple to set up. So we import some libraries, including here you can see the AS7341 library. And as you can imagine, there's a lot of data to deal with on this sensor because of all the channels of color information, and the library makes it really easy. So as Lady Ada mentioned, Sedacious did a bunch of great work to make this easy to work with. Thank you, Brian, for that. You can see I'm setting it up over I2C because I have it plugged into one of our little Stemma QT connectors here. And then I'm setting up the sensor. Every time I want to ask the sensor for one of those color channel readings, and here you can see it's just being used in this big print statement, it's as simple as saying sensor.channel underscore and then which wavelength section, which of those little sub-sensors are we asking for? So there's the 415, 445, 480, and so on up through 680. My very crude attempt at turning those color readings into neopixel colors was just to read on the red, green, and blue channels and then take that 16-bit data and chop it down to 8 bits. Thanks to my friend Todd Bott, by the way, for a tip on how to do that neatly here with this little piece of code. And then that just tended to be sort of low numbers, so I was tripling them to get up to something that looked good on the neopixels. I may be able to, let's see if I can look at the raw data here. Yeah, oh, you know what? I think maybe it wanted to be, let's see, will it work now? Will it? Yes, maybe. No, Something's goofy going on. It might be because of my serial readout there. Sorry about that. But I did have this working yesterday where it would try to read that. Yeah, it's just getting green all the time on that. I'm not sure what's going on with the NeoPixels. I broke something. But you can see just asking for those levels. I think that part, no, there it started kicking in maybe. I'm having to hit spacebar to advance the poor serial reader. But you can see as I'm looking at this sort of yellow bulb, I'm getting higher readings in yellow and orange there. If I switch over to a blue bulb, we should see we get indigo and blue with pretty high values. I don't know what broke with the NeoPixel part of this, but you can see there it's pretty straightforward for you to just ask the sensor, hey, what values are we getting, what 16-bit values are we getting in each of those 10 channels? So a lot of data to deal with, but a very cool sensor, a lot of interesting applications that you could find for it. As Lady Anna mentioned, could be useful for different types of laboratory experiments. You could use it for trying to do color matching for photography or video stuff. It even has some flicker sensing built into it. So one of the sensors on there is able to discern a 50 hertz or 60 hertz flicker, which is common with some lighting, in order, I believe, to then use it to get a more accurate overall lighting condition for camera work. You could probably also use it in a more advanced setting to try to counter flicker in video acquisition. So that is my product pick of the week. It is the multi-spectral sensor. There you go. That's the product pick of the week. In fact, I'm going to do this one last time so I get a neat, easy to edit video. So thanks for bearing with me. There we go. That is my product pick of the week. It is the AS7341 multispectral light and color sensor in STEMMA QT format. I'm going to go ahead and put that on my STEMMA QT wall of goodness. And that's going to do it for this week. Thank you so much, everyone. And don't forget, you can head over to this URL right here, right now. Go to that product page and pick one of these up for half price. I think there's a limit of 10 of them that you can pick up during this time, and no resellers, so just for your own nefarious purposes, not for reselling, or maybe not so nefarious. Tell us what you do with it. We're interested to see how you incorporate this cool little sensor into your projects. Thank you so much. This has been JP for JP's Product Pick of the Week. I'll see you next time. Bye-bye.